niya sa iyang essay or sa iyang paper na entitled na Essay on Determining the Relative Masses of the Elementary Molecules of Bodies, where he suggested that equal volumes of gases at the same temperature and pressure contain an equal number of molecules. This groundbreaking idea laid the foundation for our modern understanding of the behavior of gases and the development of the concept of the mole.
So what really is Avogadro's law? Avogadro's law is a principle in chemistry that states that under the same conditions of temperature and pressure, equal volumes of gases contain an equal number of molecules. The key concept of Avogadro's law is the idea that at the same temperature and pressure, a fixed volume of any gas will contain the same number of molecules, regardless of the type of gas. This implies that the molar volume of gases is constant under this condition.
Avogadro's law is expressed mathematically as follows. V is the ratio proportional to the N. V is the volume of the gas and N is the number of moles of a gas. This means that if you double the number of moles of a gas with constant pressure and temperature, the volume of the gas will be doubled. Similarly, if you reduce the number of moles by half, the volume will be half.
What is Avogadro's number? Avogadro's number is a fundamental constant in chemistry that establishes a relationship between the macroscopic world measured in grams and the microscopic world measured in atomic or molecular units. Avogadro's number, often denoted as Na, is defined as the number of atoms, ions, or molecules in one mole of a substance. The value of Avogadro's number is approximately 6.022 times 10 to the power of 23 indices per mole. The connection between Avogadro's number and Avogadro's law lies in the idea that one mole of any substance, whether it's gas or a collection of atoms or molecules, contains the same number of entities. Avogadro's law specifically applies to gas and is a consequence of the fact that at molecular level, the volume occupied by one mole of any gas contains the same number of molecules under the same condition of temperature and pressure.
So let's proceed to the example.
One practical application of Avogadro's law is in the manufacturing of products like balloons. When inflating a balloon, the volume increases as the number of gas molecules increases. The law helps in understanding how much gas is needed to fill a certain volume, ensuring consistent balloon sizes by maintaining a specific number of gas molecules regardless of the volume. The inflation of a balloon with air, which primarily contains nitrogen, oxygen, and other gases, can be represented in a simplified chemical equation as one mole of nitrogen gas plus 1 mole of oxygen gas produces product of 2 moles of nitrous oxide gas. This equation illustrates the combination of nitrogen and oxygen in the air to create the gases that fill the balloon, adhering the Avogadro's law by maintaining the ratio of molecules when the volume increases or decreases.
Pagyan mo tayo sa side link in part sa balloon. So, kung Avogadro's law states that the volume is increased the number of gas molecules is increased. So, kung pila daw itong, let's say, an input aning kuwan, kaning so, kung ato daw if press ni night pressure sa so mo kuan siya og air dili air so musod siya diri so kung pila daw ang ipon nga air ani mao sa dang ani molecule sa air so kung nagkuhan ka sapon two molecules of oxygen and one molecule of nitrogen and one molecule of oxygen. So, ang mabutang diri two molecule of nitrogen and oxygen. Next, let's take side. So, mo siya.
Another related application of Avogadro's law is in the manufacturing and handling of gases, particularly in industries that uses or produce gases on a large scale. One example is the production of ammonia for fertilizers. Ammonia is a gas at room temperature, and its production often involves chemical reaction where nitrogen gas and hydrogen gas combine to form ammonia. Avogadro's law comes into play in the storage and transportation of these gases.
So, in line with the equation, as what Mr. Alibo said, sa katong gigamit na fertilizer is the ammonia gas. So, the chemical equation for the production of ammonia from nitrogen gas and hydrogen gas involves a combination of these gases. The balanced chemical equation for this reaction is 1 mole of nitrogen gas reacts with 3 moles of hydrogen gas to produce 2 moles of ammonia gas. So as you can see, the equation balance siya. So kanina siya nga balance equations nag-represent siya sa Avogadro's law. The balance coefficients in the equation ensure that the law of conservation of mass is satisfied, meaning that the number of atoms of each element on the reactant side is equal to the number of atoms